Greetings and welcome. This is Dr.BDY Sunil, Associate Professor, Mechanical Engineering Department, Institute of Aeronautical Engineering, Hyderabad. In today's session, we will be solving problems on frictional force implementation. The outcome of today's session will be applying the static and dynamic friction laws for the equilibrium state of a wedge and ladder application. The topics that are going to be covered are problems involving frictional force, and topic learning outcome will be understand the frictional force and implementation of friction for various systems. Let us see the problem on body on horizontal plane. This is the problem given. A block A weighing 1000 newtons rests over block B which weighs 2000 newtons as shown in figure. Block A is tied to wall with a horizontal string. If the coefficient of friction between blocks A and B is 0.25 and between B and floor is 1/3, what should be the value of P to move the block B? If P is horizontal and P acts at 30 degrees upwards to the horizon. This is the problem given. So, the figure, as per the figure given, the block A and block B, block A is tied to the wall and block B is placed on the floor and block A is placed on the block B. And the force P is being acted towards the right side direction to the block B. First work which we need to do is to draw the free body diagram for the given figure. And the free body diagram as per the condition given and the frictional forces that are being applied here along with the normal reactions would be like this. When we consider the block A, here if we apply sigma Fy is equal to 0, then it will be leading to N1 minus 1000 is equal to 0, where sigma Fy is the block A consideration and the vertical components of the forces is equal to 0. Here we are considering the equilibrium condition of the problem. So the value of N1 can be obtained as 1000 newtons. Also, by application of coefficient of friction mu is equal to F1 by N1, we can obtain, it is given as 0.25. We can obtain the value of F1 by simplifying this equation as 0.25 into 1000, that is equal to 250 newtons. And applying sigma Fx is equal to 0, we can get the value as F1 minus T is equal to 0, which implies T is equal to 250 newton, where T is the tension that is acting in the string. Now when we consider the block B, here if we apply sigma Fy is equal to 0, all the vertical component forces is equal to 0, we can get N2 minus 2000 minus N1 is equal to 0. We already have the value of N1 here, so N2 value will be 3000 newtons. Also, the coefficient of friction mu value is given as 1/3 in the problem. So, substituting this, F2 will be obtained as 1/3 into 3000, that is equal to 1000 newtons. If we apply sigma Fx is equal to 0 for the system, where all the horizontal components of the forces is equal to 0, can be considered as P minus F1 minus F2 is equal to 0. Depending on the direction of the frictional forces and the normal reactions and the force that is being applied, we need to consider the sign convention. So the value would be P is equal to 250 plus 1000, and that gives 1250 newtons. Now consider the second case where the force P is acting at 30 degrees to the inclination. For consideration in the block A, Fy is equal to 0, sigma Fy is equal to 0, it will lead N1 is equal to 1000 newtons. And mu is equal to F1 by N1, which will lead F1 is equal to 250 newtons. When we consider for block B, we can apply sigma Fy is equal to 0, where the vertical component forces in this system would be N2 minus 2000 minus N1 plus P sin 30. So that will lead N2 as 3000 minus 0.5 P. Also, if we apply mu is equal to F2 by N2, given as 1/3, we will be obtaining the value of F2 as 1/3 into 3000 minus 0.5 P is equal to 1000 minus 0.5 by 3 P. When we take sigma Fx is equal to 0, all the horizontal component forces is equal to 0, which will lead P cos 30 minus F1 minus F2 is equal to 0, which gives P cos 30 minus 250 minus 1000 minus 0.5 by 3P is equal to 0. When we solve this equation, we will obtain the value of P as 1210.43 newtons. Now let us see the problem on an inclined plane. The problem given is what should be the value of theta in figure that will make the motion of 900 Newton block down the plane to impact. the coefficient of friction for all contact surfaces is 1 by 3. So here, as if the previous problem, the upper block is being tied to a wall or any support and the lower block is free. Now they are asking us to identify the value of theta, which makes the 900 Newton block to slide downwards even though no force is being acted here. In the previous case, the force P is acted, but here the force is not present. But by the inclination, rise in the inclination, the 900 Newton block will try to move downwards. So that limiting friction condition, the inclination theta is being asked. Here, let us take the free body diagram of the given figure for block A, first block 300 Newton block and 900 Newton block. First consider the 300 Newton block here. Here, sigma forces normal to the plane is equal to 0. When we take this condition, we will be getting the value of n1 minus 300 cos theta, that is equal to 0, which gives n1 is equal to 300 cos theta. Also, mu is equal to f1 by n1. This will lead to f1 is equal to 1 by 3 n1, that is equal to 1 by 3 into 300 cos theta, which gives 100 cos theta. For the same case, when we consider the 900 Newton block, taking sigma forces normal to the plane is equal to 0 gives n2 minus n1 minus 900 cos theta is equal to 0, which implies n2 is equal to n1 plus 900 cos theta, gives 300 plus 900 cos theta. So, doing the summation, n2 value would be 200 cos theta. Also, mu is equal to f2 by n2. So, f2 is 1 by 3 n2, that is equal to 1 by 3 into 1200 cos theta, that is equal to 400 cos theta. Now, taking sigma forces along the plane is equal to 0, we will be getting f1 plus f2 minus 900 sin theta is equal to 0, which gives 100 cos theta plus 400 cos theta, that is equal to 900 sin theta. This will lead to tan theta is equal to 5 by 9. So, the value of theta can be obtained as 29.05 degrees. So, this concludes the session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.